Okay, hello guys. Tonight I will show you how to prepare a PDF probability distribution function by using R. So this probability distribution function is very useful to understand the distribution of maybe many climate parameter like rainfall, temperature, and so on. But usually I use it for rainfall and temperature to see if there is increasing intensity, increasing peak, or increasing extreme rainfall, lower quantile, something like that. So it's easy to understand the pattern of our rainfall and to compare between historical data and future data and something like that. So I will show you what we are going to prepare actually. So let me oh, yeah, okay. So let me share the screen. Okay, share. Okay. Okay, what we are going to do is we want to prepare this kind of PDF. PDF. So this is the PDF. As you can see, we can see the density of the rainfall. If the higher right tail here, we understand that if the tail is to the right, it is there is more extreme value, and the peak and different peak mean different intensity of the rainfall. So yeah, a lot of information we can understand from PDF, and we can use this for validation. We can use to compare between different period of rainfall, and many useful thing we can do this for our research. I will use PDF, and recently I also use CDF for presenting this kind of result. So let's do this. So this is the code that I use, PDF. Sometimes I use it for validation. So as we can see here, I want to validate the chips rainfall against the uh, top performing GCM. I want to see if the top performing GCM that I was investigated is really can simulate the observed data, which is chips rainfall. So for this purpose, we need to install the library ggplot2. So we can run this one, ggplot2, and then we also need a tidyverse, and then we also need library E1071. Okay. Now that we have run the GCM, we need to run our data. So we only need one CSV file. So let's go to our working directory. So IC ensure, let's see IC ensure PDF top GCM. Okay, here. So what we want to do is we have this validation dataset. So usually when we want to compare the PDF, we can either use monthly data, daily data, annual data, but most people use it for daily data or monthly data. Most of it is using monthly data. So we have this year, month, because PDF we use for temporal assessment. So we use year and month here. So and then we have observed data here, chips rainfall for every month from 1981 to 2014. And then I want to compare this performing GCM that I found after some analysis. I want to compare two of this GCM is either this top GCM really can simulate chips rainfall. So two of these GCM will be compared with the observed one. So make sure that you have the same length of the dataset for the observed and the GCM. So we will get these three dataset. So now we can read the data. If we view the data, we can see that the data is already there. You see, we can already read the data year, month, chips, and this 2 GCM. And then we read only for actual data, observed data, that 3, which is this one just now. We want to column number 3, which is chips rainfall. So this will be our actual data. And then we want to compare it with our GCM, which is column number 4 and 5, GCM and GCM2. So column 4 and number 5. So we already read column number 3, chips rainfall, GCM1 and GCM2. So now, actually we don't need this one, but I just put this one because And because I use this previous code, the level is like this, and I'm very lazy to compare this one. Actually, it's just the same thing. So we read this as TGCM1 and TGCM2, and then we put it into as a data frame. So the rainfall will be actual rainfall, which is observed rainfall just now, CHIPS rainfall, and then TGCM and TGCM2, which is column number 3, column number 4, and column number 5. And then we give a legend for this one, so that it will have the same names, which is CHIPS for actual rainfall. This is the name of the first GCM, and the second GCM, this is the name of the second GCM. So each legend the length is equal with the CHIPS rainfall. Okay. Now we calculate the PDF by using kernel density estimation. We use the density function for observed rainfall. So we can if in case there is a missing value, we can get an ARM equal to 2, and then for GCM1 and GCM2 we do the same thing, density for TGCM1 and TGCM2, and then we plot the PDF by using ggplot2. So ggplot2 data frame, EES rainfall, color legend, this density alpha 0.5, and then we do a geom line. This geom line is the one that will produce this line for each of the PDF. So we have a geom line for PDF actual. After we calculate the kernel density just now, for this is XY for CHIPS rainfall, and then we give the color name, and then this is a PDF for first GCM, PDF for the first GCM here, and then this is geom line for the second GCM. You can add more if you have more PDF that you want to compare, but in this case we have 3 PDF will be produced in the same plot. So we put xlab, so this is the x-axis as we name it as rainfall, and ylab we name it as density, and then we give the title for this plot as PDF for CHIPS rainfall against top GCM, and then we put a scale color because we want to have a different color for different PDF. So we give a value CHIPS rainfall as black. Usually the observe we put black, and then the first GCM I put red, and then the second GCM will be blue. And then the legend, I put the legend color for the legend. So you can, because sometimes if it's by default the word legend for the word legend will disappear, or it's become very small, something like that. This here I will just delete it by using pen because I don't like it. But anyway, the word legend there that will tell you that the legend is CHIPS and the 2 GCM. And then team BW, team legend, this is the position of the text box plot that we want, the size, element text, because sometimes the size of this legend is very small, and when we want to publish our paper, we always being told to make it clear, and so I make it bigger. So element text will be size 25, which is sufficient. Okay. Now we can run this code. Let's see. We can run this. You see? Okay. Now we can we produce this PDF. Very nice. So the CHIPS rainfall, as I tell you just now, I put the legend here. If you put it default, it will tell something color or something like that. It's not good legend, but it's still very small. And yeah, if you have some time to make it bigger, then make it bigger. But for me, I will just copy bitmap. I will put it into pen, and then I will just remove it. I don't like it, so I will just remove this one, put it somewhere else, something like that. So it's okay. But we will already produce our PDF like this. So we can compare the CHIPS rainfall. We can see CMCC, CM2, SR5 can simulate the pattern very well. But in the right tail, it's not simulate very well compared to CMCC, SM2. This is only one way to see if our GCM can simulate the observed rainfall pretty well or not. But this is only one way. But after this, you still need to do a statistical assessment to see if which GCM is actually better. So other than this one, I have prepared how to calculate the kurtosis. So for kurtosis for actual rainfall, you can use the function kurtosis. So sometimes we have the PDF, right? We have the PDF just now. But sometimes we have to calculate what that we can discuss about the pattern, about the shape and so on. But sometimes we need to have the value also to strengthen our analysis. So some of the important value for PDF is the kurtosis. Kurtosis is the peak of this PDF we can compare. So like for here, we can see I can calculate the kurtosis for actual rainfall, which is chip rainfall. So the kurtosis is 2.18, and then maybe you can see, okay, this is the kurtosis for chip rainfall, and then I'm calculating the kurtosis for the first GCM 2.5, and the kurtosis for another GCM is 0.046. So yeah, you can see what the kurtosis means, but this is also some of important information when you make a discussion about the PDF. Maybe you can discuss here, put somewhere when you discuss about the distribution of the GCM, and then you can tell the kurtosis is this, and so on and so forth. So your argument, your discussion about this value will become stronger. So this is how you prepare the PDF by using R. I hope this video will be helpful for your research. Okay, thank you for watching. If you have any question, just let me know.